Oh, here we go. Share screen. That's what I'm looking for. Okay. So basically, well, let me start off by just declaring who I am as usual. I'm Sam Falvo, and I apologize in advance for the loud ass laptop fan that I have. But yeah, basically, what I'm trying to do is trying to port over a fourth implementation to a 65816 processor, but I'm not really happy with direct or indirect threading because it's basically eats into the performance of the system by about a factor of two. And I would really like to have a fairly quick and snappy system. And plus, I'd like to be able to experiment in the future with different Piley technologies and stuff. So I figured the best way forward for that would be to use subroutine threading instead of direct or indirect threading, which is more conventional for the fourth environment. Now, in moving forth, Brad Rodriguez writes that if you have native hardware that supports some functionality in fourth, then you should obviously use that. And the 65816 processor does have a hardware stack, and it's actually quite unlike the 6502 that preceded it. The stack is actually much more useful for passing parameters and for recording results. So one might think, okay, well, why don't we use the facility that will be most often used, that is the data stack? Why don't we map that to the actual hardware stack instead of managing the stack in software? And it's a reasonable thing. It's a reasonable thing to consider. It doesn't quite work out the way you would expect. And hopefully, as you can see here, I've written a blog article on what I found, and I'm hoping to basically just summarize some of my findings. And of course, basically, just to recap, the 65816 processor is a 16-bit update on the 6502 architecture. So as you can see here, for example, all the registers are 16 bits. The accumulator, your index registers, the stack pointer, and your program counter. There are additional registers, such as the data bank register, the code bank register, direct page register, all these other things, but they're not really relevant to the operation of a fourth environment. So I'm not going to focus on those. So the idea is there are essentially two ways of implementing subroutine threading on the 65816 processor, and that's where you use the hardware stack, that is to say the stack that's pointed to by the S register, for return stack purposes, and you have the approach where S is used for data stack purposes. And the question that I wanted to answer is which one would be faster? If you look at internet sources, all the subroutine threading examples basically follow with the same recipe of implementation. The question is why? They never really explain why they just kind of default to this one method. And the method that they use is where S register points to the return stack rather than the data stack. So the idea is I want to find out and actually quantify the difference, if any. So basically what we do, or what I do, is I basically just count cycles depending on how which method is actually used. Here, for example, I've written I've written an implementation of the primitive plus. This basically just adds two numbers, and in this case, um, I'm using S to point to the data stack. So you can see here I'm pulling two numbers and then adding it and then depositing it back onto the stack. And basically this comes to somewhere in here. I've got, yeah, here we go. Basically it comes to a total of 38 clock cycles to complete this operation. That includes the overhead for the subroutine call and the return. So anytime you use a plus operation, you're looking at consuming about 38 cycles. And then I go in, I also do some higher level analysis. The idea here being the performance of a primitive may or may not be the determining factor of what really impedes performance on a threading implementation. So I decided, okay, well, let me take a look at what would happen in a higher level fourth word, where basically the colon definition invokes primitives or other colon definitions. And that's kind of what I'm examining here. So collecting some numbers here. We already know, for example, that the addition takes 38 cycles. So all we really need to do is to sum up everything that comes around it. So that's essentially, and I did this for a couple of different levels. Here's a case where a colon definition calls a colon definition, which then calls a primitive, for example. And yeah, I mean, you can see that the clock cycles are really starting to add up. Now, if we take a look at a more conventional implementation method, we find that where did I put it? Somewhere in here, there's an implementation. Oh, here we go. Yeah. So this is basically what I wanted to really point out here. If you use S to point to the return stack, then there's no need for stack shuffling or anything like that, because if you use the subroutine call function, the return address is already deposited on the return address, the return stack, and so you really don't have any of the additional overhead. On the other hand, if S points to the data stack, well, now we've got a problem, because as soon as you execute the JSR or jump subroutine or subroutine call instruction, your return address is now on top of the data stack. So what you need to do is you need to pull that address off and plop it onto the return stack manually. And that's what these little wrappers do basically here. And the idea is you grab that data, you put it onto the software managed return stack, and then you update, in this case, the X register as the return stack pointer. And then hopefully, whatever is happening here on the inside would take up so much time that the cost of these cycles is amortized into something that's quite reasonable. Unfortunately, as I did the calculations, that doesn't happen ever. The 65816 just does not have the instruction throughput to make that happen. The inspiration for this actually comes from the PC, in particular a direct threaded implementation of Forth called Pygmy Forth, which is my very first Forth system that I ever used. And that system, as I recall, used SP and BP as your return in your data stack pointers. And as code would run, you would always see exchange SP-BP, exchange SP-BP. So the role of the stack pointer, the hardware stack pointer, would change. It would alternate between return stack and data stack. If the 65816 had such an instruction, I think this could probably be a reasonable implementation. But since it doesn't, we have to manage all of this stuff in software. So in order for this to even make an inkling of sense, we're looking at here 14 cycles. Here we're looking at that's 9 and 4 makes 13 and 6 makes 6, 7, 8, 9. So that's 19 plus the 14 that's over here. Basically we're looking at around 30, again, pretty close to 38 cycles. This inner chunk here would probably have to cost somewhere in the vicinity of 600 to 700 cycles before the surrounding prologue and epilogue code becomes essentially free. And as we know with fourth code, that's going to be hard to do because fourth code tends to have very shallow call stacks. So as a result, not a good idea to use the hardware stack as the data stack with the 65816. It's very counterintuitive. I actually thought that it was going to be at least competitive, but as we can see here with a 37% performance hit, it's not even in the ballpark. So if you're going to write a subroutine threaded code interpreter for the 65816, follow the common wisdom and build it so that the hardware stack pointer is in fact a return stack pointer, and manage the data stack manually in software. It turns out that is a significantly faster approach, perhaps counterintuitively as it was for me, but it does actually work out correctly. One of the reasons that I find that this is the case, and I realized shortly after doing this, what makes this work is exactly what makes high performance subroutines in RISC processors work. And it's the same idea. Basically, what you do is you adjust your stack pointer once, and then you amortize the cost of that adjustment across multiple stores and multiple loads. And in doing that, the cost of saving and restoring your register state is significantly reduced. And so in the case of the 65816, you would basically adjust your X register, which would be your data stack pointer, and then you would make frequent uses of the DP, direct page index addressing mode, which typically doesn't get used very often in the 6502 environment. But here in the 65816, it actually finally makes a lot of sense. You make frequent uses of that addressing mode, and suddenly, you're actually writing some decent performance code. So I thought this is kind of a quick and dirty analysis of which approach to write subroutine threading with the 65816 processor. So my recommendation: definitely use the S register for return stack and use the X register for data stack, which allows using that addressing mode, and that allows you in turn to write the fastest possible subroutine threaded logic that you can. And that's basically it. This is, like I said, this is just a quick walkthrough. I'm open for questions either now or afterwards. You can also reach me on the SVFIG mailing list as well. Yay, more stunned silence.
Okay, doesn't sound like there are any questions for Sam. I would like to go ahead, Ting. Did you have something?
Yeah.
Okay. I'd like to ask all of you, while I've got you here, to think about what you're going to present on fourth day. I'd be grateful for as much advance information about that as we can manage. The usual arrangement is that this thing sort of comes together in the last few days before the event, which is not as organized as I would like to be. So Tig, I noticed you on mute. Did you want to say something?
Oh, I think the just one comment on the subroutine threading. The in the original design of E4 system, that was direct threading, okay, and then then I found that subroutine threading is much faster, much easier to do, because you can inline assembly code with subroutine threading code. So it's getting faster, and it's more convenient. But the only problem is the size. That depends upon the number of bytes that you need in the subroutine call. Some of the processor, the subroutine call, gets very expensive. For example, the 8086 architecture, the subroutine call costs you 5 bytes, and the direct threading needs only 2 bytes. So that's a trade-off. But I think nowadays the memory is not a problem anymore. So subroutine threading is much more appealing. Yeah.
Yeah, the 65816 continues to support a 16-bit subroutine call. So those instructions are actually only 3 bytes long.
Yeah.
So you have the opcode and then the two address bytes. Of course, you're limited to a 64K code bank size, but that should be plenty accurate, or plenty enough for what I'm looking to do. It does also support a 24-bit subroutine call as well, but I don't have any plans to use that.
Yeah, I think subroutine threading is definitely the way to go.
Out of curiosity, Sam, not knowing the architecture well, is that's the 16-bit one? Is it a relative address, or is it sort of in chunks?
No, it is very much a it is very much a chunked. Basically, the effective address of a 16-bit subroutine call is, quote, the current program bank. So you have access to 64K window within a 16 megabyte address space, and that bank is set by the program bank register, which is an 8-bit register that I didn't disclose because I didn't need it. But yeah, it's there are 16-bit program relative branch instructions, but they're not subroutine call instructions. So they're unconditional branches, unfortunately.
Cool, interesting. I take it that's a legacy of it being sort of compatible with 6502 and such.
Yeah, the history of the 65816, being an update to the 6502, it's actually interestingly quite intertwined with the evolution of the Apple II GS, as well as the Acorn family of computers from the BBC. I'm sorry, the Acorn computers before they developed the ARM processor. In fact, the 65816 is what motivated or convinced Sophie Wilson to start designing the ARM chip. So a little bit of interesting computer history there, but yeah, it is a bit of a Franken architecture. So
Any other comments, questions for Sam? All right, let's move on. Any of you among us care to present anything else? We've got this is the portion of the program where we accommodate walk-ons. So think about that for a minute and we'd be pleased to hear from you. While we're thinking about that, I'd like to mention that Sir Sinclair passed away, and he is among celebrities, perhaps the one I can think of whose name is associated with Forth, and gave us the thing we think of as a Forth product that might have the widest recognition. I see Dave has put up the Wikipedia and the Guardian obituary, but I guess Clive Sinclair met the end to his stellar career with this little runabout sort of a Segway reclining electric scooter that was widely unaccepted. It never found its feet in the world. I think one of the problems was that it wasn't very visible in traffic, and people didn't feel like they needed to get on board. How many of you have any experience or knowledge of the Jupiter Ace? Ever seen one, touched one, got involved with using it in the world or in an emulator?
Well, the Jupiter Ace is what actually inspired me to work on the Kestrel computer family. So Kestrel 1 wouldn't have existed without it.
Are any of you conversant with any of the emulators, the Jupiter Ace emulators that run under Windows or other?
I have the XA simulator installed on my laptop. It's an interesting architecture. I've spent a lot of time actually sort of studying it in various ways. Especially, it's one of the few systems that sort of confronts all of the issues of if you've got a Forth on a system and it really has to be the whole system, and you really have to sort of offer that same set of capabilities of computers of that era. There's challenges about it lets you redefine words and things like that are different in ways that sort of seem unique.
Would you be willing to present a short getting started with that emulator, where to go to download it, and what it looks like and give a short demo in October. Brad?
Yeah. For a while, they actually, it's very sad that it went down, but there was a web-based emulator that was nice because they had the entire library of software that had ever been published for it, and it was up on the site, and you could just go to the page and interact with it on the web page and so on. But something seems to have happened to it.
All right then. So while we've been thinking about presenting any kind of a quickie, nobody has sent me a direct message or spoken up. So I think that means that there isn't one. It looked like Mr. Armstrong's prepared to go ahead. What I'd like to do is propose to pull the recorder off maybe a little early today, with the goal of having our talks all fit the format of 20 to 30 minutes, so that we can hold the attention of our Zoom and our YouTube audience. So if anybody else has anything to say, now's a good time. I wanted to make a comment about the Mountain View Press and their archive materials. What I plan to do in October, since it seems like there aren't any good alternatives. What I have to do in October is maybe spend the morning hauling the bulk of the material, saving 2 or 3 items from each box, maybe 3 or 4 from each box, that I might be able to keep here, at least for a time, at my house. So I'll set aside some things for what the Computer History Museum might want, or other repositories, or it's interesting that of the folks that I've tried to contact, there hasn't been there hasn't much excitement in receiving any of this stuff. So it just goes to show you. So what I'll do is spend the morning hauling material and stacking it up in my driveway, and then getting a contractor to come and haul it off from my driveway, rather than spend the money to have them wind their way through the 100 yards from the elevator to the storage locker at the storage facility. So that's my plans as it is. I may have mentioned before that there's at least one guy in Australia that would like me to ship him some stuff. And I have tried to work on that in fits and starts. It seems like the horrifically expensive prepaid mailer, US Post Office, is the best way to do that. So if anybody has ever shipped books to Australia or anything to Australia, please get in touch with me. If you don't know my email address by now, arthur@comcast.net, and can't find it on the internet, you're not as astute as many of the people that mass market to me, if I may put it that way. Comments? Anybody? Australia, shipping, post office, other?
Yeah, the Kevin,
Yes.
I think, you know, I tried to do some mailing a long time ago. You know, long time ago, they used to have a post bag service that you can put lots of books into a post bag, and they will ship the entire bag anywhere in the world very cheaply, because they have the UN has a agreement everybody signed, all countries signed, that they would provide service shipping books or printed material. But the post office stopped that some 10 more years ago. So there's no longer this cheap way to ship books. But the best way now, it looks like if you can arrange the bulk shipping through a shipping company, and that the cheapest way to send things around. Yeah, I had a couple of friends who shipped a large amount, tons of material from San Francisco over to China, and at a very reasonable rate. Okay, so but you have to arrange get a shipping company which can do the you have to do some kind of preparing, put them into boxes, and so they can ship them in the bulk. Yeah.
Yeah, the amount of stuff that I plan to send is more on the scale of the prepaid than on the tons of stuff. Maybe if I could ship the entire Mountain View pile of boxes to Australia, they would come and seek me out and arrest me.
Yeah, I think that what they do is they do a big wood pallet and wooden boxes, so that they can ship in containers.
Yeah.
Yeah, I think that there's a way to do it, but
yeah, this is more on the order of less than 20 pounds, probably.
20 pounds. That's
It's
that's
off the radar.
That's the most expensive thing to ship around.
Yeah. Well, you know, I had the expectation that with the vast array of folks on the email list and in this forum, that somebody would just say, "Oh, that's trivial, easy, and won't cost you more than $20." And I'm sadly disappointed. But one more thing before we hand it over to Bob Armstrong and tell Brad that he's gonna pull the plug on the recorder half an hour after Bob starts. The thing I'd like to say is that I'll hope to hear from anybody that wants any of this stuff, because this is really the last round. The storage facility and my ability to send things to people is just too psychologically draining. I hate putting things in one storage. As the much missed Alan Furman said, it's just like putting stuff in a dumpster, you know, in delayed in a delayed way. So Brad.